Okay, so let's just take a look at the two questions that were on the 8.2 Part 2 homework. You had to solve the equation algebraically or graphically, so I did it both ways, in case you did one way or the other. If you solve it algebraically, the first thing you want to do is divide each side by 2, and you end up with cosine of 2x equals root 2 over 2. And then I do the cosine inverse of root 2 over 2, but I already know that the cosine of 45 degrees is root 2 over 2. But you'll get 45 degrees anyway. But that's what 2x equals because it's not x. So cosine inverse of root 2 over 2 is going to give me this angle measure 2x. So that's twice the angle measure I want. So I know that at 45 degrees, I'm going to have twice the angle measure I want. Also, cosine is positive in quadrant 1 and 4. So in quadrant 4, my reference angle will be 45 degrees. So that's a 315 degree rotation, but that's twice my angle measure too. So I have to cut those both in half. And since the period of this function, I put it in radians for some reason, since the period of this function is 2 pi over 2, or pi, that's 180 degrees. That means this repeats itself every 180 degrees. So this angle measure right here at 22.5 degrees, add 180 degrees to that, and you'll get this one right here. This angle measure, 22.5 plus 180 right here. And this angle measure is a quadrant, well, I don't want to say quadrant 2 angle because it's twice the angle we want. But this angle measure right here is 157.5 degrees. But since the period of this function is every 180 degrees, just from here, go another 180 degrees, and I have 337.5 degrees. I graphed y equals 2 times the cosine of 2x, and then I graphed y equals root 2 over here, 1.4-ish, and the intersections will be those angle measures. For the second problem, again, the period is 2 pi over 2, so it's pi. This repeats itself every pi or every 180 degrees. I put it in terms of pi here for some reason. It should be 180 degrees, but that's okay. So if you solve it algebraically, you're going to have that 5 times the sine of 2x equals 4. Divide each side by 5. You'll get sine of 2x is 4/5 or 0.8. So the sine inverse of 0.8 is equal to twice the angle measure I want, because that's 2x that I'm going to get out. So that's about 53.13 degrees. So I know that this angle measure is 53.13 degrees, but sine is positive in quadrants 1 and 2. So this reference angle of 53.1 degrees will give me another angle measure to set equal to 2x. Okay, so that'll be 180 degrees minus 53.13 is 126.9, but that's also equal to twice the angle measure I want because I have to double the angle measure and then take its sine. So 2x is 126.9, so divide by 2, you get 63.4 degrees. And since the period is 180 degrees, it keeps repeating itself at 180. Just add 180 to both of these angle measures, and you get the other two angle measures between 0 and 360. So between 0 and 360, there's 4 different angle measures that make this equation true. And what I did over here was I graphed y equals sine of x for 2 periods. And then I graphed the line y equals 4/5 or y equals 0.8. And they intersect at those 4 angle measures. Okay, so I put my axis in radians even though it's supposed to be in degrees. Right? Hope that helped.